Today's lesson is over section 5.8, which is the rational zero theorem. The rational zero theorem gives us a way to narrow down the possible rational zeros that we can test using synthetic division. Let me explain by looking at the example below. If you look at number 1 right here, you see f of x is equal to 2x cubed minus 11x squared plus 12x plus 9. Unfortunately, it cannot be factored by grouping, so we can't just know what the zeros are. That's where the rational zero theorem actually comes into play, because the rational zero theorem gives us a list of possible choices that might work when we use synthetic division. The thing is, if we're at a cubic, which this is a cubic, degree 3, we only need to find one value to work to go from a cubic to a quadratic. And the good news is once we reach the quadratic level, if we can't factor the quadratic, we can also always use quadratic formula. So I want to find a value that works here so that I get a remainder of 0 here. Because if the value goes in evenly, I know that I have found a viable 0. So that's what I'm looking for. I'm looking for something that works in my little half box that produces an output of 0 for my remainder. And I don't want to just pick values out of the sky. So you can notice I've labeled the constant term in my function as p above the function, and in the first term, I've labeled above the 2 q. And that's because up here it says p is a factor of the constant term and q will be a factor of the leading coefficient. And p over q is going to be a possible rational zero. So let me, above the problem here, I'm going to change my color of my pen. P, I'm looking for all the factors of 9. Because zeros can be both positive or negative, I need to list plus or minus. But the factors of 9 would be 1, I'm just going to list plus or minus once, 3, and 9. And for Q, the leading coefficient, which is 2, the only thing I would have for factors of 2 would be 1 and 2. And again, they can be both positive as well as negative. So P over Q, you will notice I crossed out f of the opposite of x. For now, that's not something you need to worry about. But P over Q is going to be all the p factors over all the q factors, and I need to think of them separately. So I need to take 1 over 1, which is 1, 3 over 1, which is 3, 9 over 1, which is 9, and then I need to take each of those p factors over 2, so that gives me 1/2, 3/2, and 9/2. And remember, I'm trying to solve this equation and find the zeros. And the first thing I want to say is I do not want to start with the fractions. I think I'm going to start doing synthetic division, one at a time. I can start with positive 1, and, this would be 2, this would be negative 9, this would be negative 9, 3, and 3, and clearly that doesn't work. So I need to go back and try a different value. So I could try negative 1. That's the next value. So if I put negative 1 here, this would be negative 2, negative 13, positive 13. I can begin to see this is not going to work, so I'm not going to use that one. Now, it may look like, why are you going to try all of these? but this is better than just picking random numbers out of the sky. So next I'm going to use positive 3, and this would be 6, negative 5, negative 15. This shows promise, and we found one that works. And it may not be the only one, but I'm just going through my list. You have to test both positive and negative P over Q values. And once you get that remainder of 0, like we did here, then we found one that works. What that means is f of x at this point factors into, since 3 worked, that's the 0, the factor would be x minus 3, and then the coefficients in my depressed polynomial, which is just the polynomial that results from your synthetic division, would be 1 degree less, so that's going to be 2x squared minus 5x minus 3. The hope is, because we're asked to find all the zeros, is that that is going to be factorable. Worst case scenario, if it doesn't factor, then you can use quadratic formula because you're at the quadratic level. The good news is this is factorable. And let's see, it's got to be 3 and 1. I'm going to have to put the 3 here and the 1 here. Minus 6 plus 1 would make it negative 5x. So by setting each of those factors equal to 0, I get my zeros. Obviously, if x minus 3 equals 0, we already knew this one. That gives us x equals 3. So that's our first 0, 3. If I set 2x plus 1 equal to 0 and solve, that's going to produce negative 1/2. So that is my second 0. And then the third 0 is actually a repeated root. You don't have to write it again, but it is a repeated root. If you want to write it again, that's fine, just to count it. But you have the zeros of 3 and negative 1/2, and 3 is a repeated root because it occurs more than once. So, do you see how the possible rational zeros can lead you to your outcomes for your zeros? All right, let's try our second equation, which is a quartic. It's degree 4, so we are going to do the same thing, but this time we are going to have to do synthetic division more than once, because the first synthetic division only takes us from a quartic, degree 4, to a cubic, degree 3. So P, I can't write very well above the equation, but remember, P is a factor of the constant term, 30, and Q is a factor of the leading coefficient, which we have to recognize as 1. So let me list those out. My P factors for 30, it does include both plus and minus. So that would be 1, 2, 3, 5, 6, 10, 15, and 30. There are a lot of them. Oops. Let me move that down. The Q factors, the good news is just plus or minus 1 because the coefficient's 1. So really, my P over Q values here are the same as my P values. They include positive and negative 1, 2, 3, 5, 6, 10, 15, and 30. I'm not going to write them all again, but you should understand that my P over Q values are the same as my P values because Q is just plus or minus 1. So I'm going to start with positive 1 here. With my first synthetic division, that would be 1. Sometimes as you start this process, you can see there's no way it's going to work. And I can see that that's not going to work. So I'm going to go back here, and I'm going to try negative 1. So this would be negative 1 and 0. This would be 0, so negative 19. This would be positive 19, and actually this is looking promising. So we found our first synthetic division that works. That means that the coefficients I got are giving me the cubic level. In fact, I could write it. This means it factors into x plus 1. That's from this 0. That worked. And then the coefficients are 1 degree less. So it's 1x cubed. I don't have an x squared term because I have 0 there. Minus 19x plus 30. Now, I don't really need to write it here, but I just wanted you to recognize that is that polynomial. So I'm going to work off of what I had. I'm going to piggyback on the synthetic division I already had. So that's kind of cool, and I want you to see that. I'm actually going to put a half box right here, draw another line, but I'm not going to have an extra column. I am going to have one less column because I have one less degree. So now I'm going to go back and I'm going to continue trying my zeros. Sometimes a 0 can work more than once. Like in our previous problem, 3 was a repeated root, so it actually could work more than once. But I always want you to stop at the quadratic level. Once you reach a quadratic, no more synthetic division. You just do factoring and quadratic techniques to practice with quadratics. So here we're at a cubic level. So I'm just going to continue, and I'll use positive 2. And if I do synthetic division, that would be 2, and I'd add, this is 4, negative 15, and that's negative 30. And the good news is I got that remainder of 0. So now I'm actually going to write my polynomial. So f of x, I know, has to equal x plus 1. That comes from the first root that work. Then x minus 2, that comes from that root. And then I went from a quartic degree 4 to a cubic degree 3 from the first synthetic division, and then from the cubic to the quadratic from the second synthetic division. So my coefficients 1, 2, negative 5 are quadratic. That's 1x squared plus 2x minus 15. Now, my hope is that I can factor that quadratic. Again, if I can't, I get to use quadratic formula. Here, I think I'm going to be all right. 5 and 3. It'd have to be plus 5 minus 3 to be positive 2. The zeros are found when you make f of x 0, because it's really your x-intercepts, the zeros or your roots. And we get negative 1, positive 2, positive 3, and negative 5. Will they always be real? No. Sometimes you might have to use quadratic formula and you'll get I in some of your roots. But that's how you go about finding them. I could go up to the top where it says zeros if I wanted. And my zeros are negative 1, 2, 3, and 5. I think in the back of the book they use set notation like that. I don't care if you use set notation, but so you understand how you're looking at the answers. So that's the process. The homework is right here. It will be on Canvas, but you are doing, it looks like it's page 370, numbers 10 to 14 even, 27, 30, 32, and 33. I forgot the page number. All right, have a great day. We will still be testing on block day, but we'll take the beginning, the first half of class to return quizzes, to go over information. But just so you know, the Thursday, Friday block days, we still intend to test, but that will be the second half of class. All right, thank you.